In this video, we're going to talk about polygons on the coordinate plane. When you're placing a polygon on the coordinate plane, here are positioning tips. You want to place the entire figure in quadrant 1. Okay, so if you notice this parallelogram right here, it's completely in quadrant 1. You want to place the vertex at the origin. Okay, so 0, 0. So see here, this vertex, it's touching the origin. And then you want to place at least one edge on the x or the y axis. Okay, so for this one, it's touching the x axis. To find the midpoint, if you're given 2 points, you use the formula x1 plus x2 divided by 2 to find the mid x point, and then you use the formula y1 plus y2 divided by 2 to find the middle y point. Okay, so for example, okay, the midpoint formula is to find the point that's directly in the middle of a line. Okay, so if I'm given a line that has points 2, 4 and negative 5, 8, okay, just like with slope, we're going to label x1, y1, x2, y2, and we're going to plug it in. All right, and so just to give you kind of a visual here, if this is 1, 2, 1, 2, so say this is 2, 4, right there, and then negative 5, negative 8. Let's say this is negative 5, negative 8. So we're going to connect these lines. What this midpoint formula does is it helps me find the point that's directly in between these 2 points. All right, so I'm going to plug these numbers in, okay? x1 plus x2. So 2 plus a negative 5, okay? Plus a negative means minus. So this is just 2 minus 5 divided by 2 to give me my x point. And then my y point, 4 plus a negative 8, is just 4 minus 8 divided by 2. Okay, so 2 minus 5 is negative 3. So we have negative 3 over 2. And then 4 minus 8 is negative 4. So that's negative 4 over 2. Okay, now the negative 4 over 2 can turn into negative 2. And for the negative 3 over 2, I'll go ahead and say negative 1.5 and negative 2. And so that's basically showing us if we went negative 1.5, negative 2, see, that's about the middle. That looks about right. Triangle midsegment theorem. Okay, we've already talked about this, right? A midsegment of a triangle is parallel to the third side and is half the length of the third side, right? So what that's saying is that the midsegment, right, it's attached to these 2 sides, 1, 2, and parallel to this third side. Okay, every triangle has 3 possible midsegments, right? Because, for example, here's this midsegment. Then say I was in the middle of these 2 points, right? That would be this midsegment right here. And then for this one right here, that would be the midsegment for this line right here. But for this particular one, KL or KH is the midsegment for triangle AGF. Okay, and AF is the line that it's parallel to. So for this one, we want to determine the endpoint coordinates of the midsegment for triangle DEF that is parallel to the x-axis. Okay, so here's the x-axis, right? EF is on the x-axis. All right, so we want to find the midsegment that's parallel. So what we're wanting to do is find the line that goes this way. So what we want to do is we'll use the midpoint formula to find the midpoint between D and E. And then we'll also use the midpoint formula to find the midpoint of DF. Okay, so for DE, remember our midpoint formula is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. Okay, so for DE, okay, I'm going to label this x1, y1, and this is going to be x2, y2. All right, so for this one, we're going to have 0 plus 2 divided by 2, and then 7 plus 0 divided by 2. Okay, so that gives us 2 over 2, which is 1. Okay, and then 7 over 2, which is 3.5. Okay, so that tells us 1, and then 1, 2, 3.5 is the midsegment right there. Okay, to find the midsegment here, okay, we'll leave this as x1, y1. We'll label this also x2, y2. All right, x1 is 0 plus x2, which is 6, divided by 2. And then 7 plus 0 divided by 2. Okay, 0 plus 6 is 6. 6 divided by 2 is 3. And then 7 over 2, we already figured, right, was 3.5. So the midsegment for this two lines, we go 1, 2, 3, and then 1, 2, 3.5. See, so there is our midsegment. And it's parallel to EF. It's parallel to the x-axis. And we know it's parallel, right? Because if we look right here, our y-coordinates are the same, 3.5 and 3.5. That means it's a straight line across. For this one, we want to use the coordinates of G to show that it is a midpoint of DE. Okay, so G is 2, 5. All right, so all we're going to do is just find the midpoint, use midpoint formula with DE, and then we're going to make sure that it equals 2, 5. Okay, so here we have x1, y1, x2, y2. Okay, so I add x1 and y1, 0 plus 4, and I divide it by 2. And then y1, y2, I have 6 plus 4 divided by 2. 0 plus 4 is 4, divided by 2 is 2. 6 plus 4 is 10, divided by 2 is 5. So the midpoint is 2, 5. So we've proven that G is the midpoint. Now I want to use the coordinates of G and H to show that GH is parallel to EF. All right, and so what we're going to do here is we're going to find the slope, right? We know parallel lines have the same slope. Okay, so remember, slope is x2 minus x1, y2 minus y1 over x2 minus x1. So now here, EF, we've already labeled this x2, y2, so let's just label this as x1, y1. Okay, so now we're going to take y2 minus y1, so 4 minus 0, and then x2 minus x1 is going to be 4 minus 6. 4 minus 0 is 4, 4 minus 6 is negative 2, and then 4 over negative 2 is negative 2. So the slope for EF is negative 2. So what I want to hope for is that GH is also a slope of negative 2. So here, let's go ahead and label this. We'll label x2, y2, and then x1, y1. Okay, so now here, we're going to take 2 minus 3. Okay, y2 minus y1, which is going to be 5 minus 3. And then x2 minus x1, which is going to be 2 minus 3. 5 minus 3 is 2. 2 minus 3 is negative 1. 2 over negative 1 is a negative 2. So M equals negative 2 for both of these. So we have proven that these two are parallel. On this one, we're going to use triangle ABC to answer these questions. We want to determine the coordinates of the midpoints AB and AC. So this line right here and this line right here. So remember, midpoint, x1 plus x2 divided by 2, then y1 plus y2 divided by 2. Okay, so we're going to do AB first. So we're going to say x1, y1, x2, y2. Okay, so now we're going to have 4 plus 2 divided by 2, and then 0 plus 6 divided by 2. 4 plus 2 is 6, divided by 2 is 3. 0 plus 6 is 6, divided by 2 is 3. So the midpoint of this one is 3, 3. 1, 2, 3, 1, 2, 3. Okay, and then the midpoint right here, for this one, x1, y1, we'll label this x2, y2. So now we're going to say 4 plus 8 divided by 2, and then 0 plus 0 divided by 2. 4 plus 8 is 12, divided by 2 is 6. 0 plus 0 is 0, divided by 2 is 0. 6, 0. So that would be this point right here. Okay. So now since I know the midpoint of these two lines, I can connect these two dots, and that means this is the mid-segment for line BC. Sorry, I lost my BC. Okay, verify that the line that connects the midpoint from part A is a mid-segment. Okay, so basically we just did that, right? We connected our lines and it's parallel, right? That's what we want to find out. So what we also want to do now is find the slope, just like we did earlier. So let me erase some of this real quick, and so I have a little room. Okay, so remember our slope formula is y2 minus y1 over x2 minus x1. Okay, or what we could do on this one, right, since we have whole points, we can just do rise over run, right? So if I go from this point to this point, I'm going to go down 1, 2, 3. So that's -3. And then I'm going to go to the right 1, 2, 3. So that's +3. So that's a -1, right? -3 divided by 3 is -1. So now I want to find BC right here. So now I'm going to go down 1, 2, 3, 4, 5, 6, right? Down 6. Oh, whoops, I didn't. 1, 2, 3. Okay, yeah. So I go down 6. 1, 2, 3, 4, 5, 6, which is -6. And then I go over 1, 2, 3, 4, 5, 6. -6 over 6 is a -1. So both of these have the same slope, -1. So we know that it is the mid-segment because it's parallel to this line right here. And that is the end of coordinate proofs.